So let's read this problem. It says, example 1, find the area of the region bounded by the graphs y equals x squared plus 1 and y equals x on the interval from 0 to 2. 0 less than or equal to x, less than or equal to 2. So what we know we're going to do is we're going to be integrating from 0 to 2 of the top function minus the bottom function with respect to x. Whatever that is, that's what we're going to be doing. So we have two functions. We have x squared plus 1 and we have y equals x on the interval from 0 to 2. We need to determine, are they ever equal on that interval, and which one is the top function and which one is the bottom function. So how do we determine this? Well, in all honesty, just plug in some numbers if you can't figure it out. So for instance, I'm going to consider some x values here, and I'm going to consider my y values. My first function is x squared plus 1. My second function is y equals x. And I need to consider values from 0 to 2. So I'm just going to pick some numbers. How about 0, 1, and 2? If I plugged it into x squared plus 1, I'd have 1. I'd have 1 squared plus 1 would be 2. 2 squared plus 1 is 5. If I plugged in x for y equals x for 0, 1, and 2, I'd have 0, 1, and 2. Notice the values 1, 2, and 5 are bigger than the values 0, 1, and 2. So that tells me that my top function here, the higher y values here, are x squared plus 1, and my lower function, my bottom function, is going to be y equals x. So go back up to your original integral. We know that this now has to be the integral from 0 to 2 of the top function. The top function was x squared plus 1 minus the bottom function. The bottom function was simply x. Do that with respect to x. Well, I'm going to clean that up a little bit. I'll write it in descending order. So this is going to be the integral from 0 to 2 of, I'd have x squared minus x plus 1 with respect to x. Now I just integrate like normal, definite integration, which means just do your indefinite integration and evaluate it at the limits. The integral of x squared is x cubed over 3. The integral of x would be x squared over 2. And the integral of 1 is simply x. Again, this is evaluated from 0 to 2. Nice thing here is plugging in 0 is always a wonderful thing for integration. We know when we plug in 0, each one of these terms has an x, so each one of these terms is going to turn into a 0. So what do I have? I'd have 2 cubed over 3 minus 2 squared over 2 plus 2. That's what happens when I evaluate it at 2. Then I'd have minus and I'd plug in my 0, exactly as I said earlier. That would be a 0. So go ahead and plug this into your calculator, see what you're getting. I seem to be getting a fraction of 8/3, improper fraction of 8/3. Okay, so what the heck did we just do? If you want to think about this, what does x squared plus 1 looks like? This would be y equals x squared plus 1. It's a nice parabola, shifted up one. Then we have y equals x, which would be below it. What we did is we looked at 0 to 2. We found the area between these two curves on the interval from 0 to 2. Again, noticing that x squared plus 1 was on top, x was on bottom, and the only way we knew this, we didn't have a graphing calculator, so we didn't graph it. The way that we knew this is simply by plugging in values. Let's go ahead and look at the next one. It says, find the area of the region bounded by the graphs of y equals 3 minus x squared and y equals 2x. Well, I've got some issues with this right away, I'm noticing. So I want the area of the region, so I know I'm going to be doing integration, and I'm going to be doing integral from a to b, and then I'm going to do the top function minus the bottom function, but I've got a bunch of questions on this one. I don't know what the top function is, I don't know what the bottom function is, and I don't know what my limits of integration are. It didn't tell me where to integrate it. So the first thing that we need to do here is find the limits of integration. Find the limits. What is a and b here? What's the area between these two curves? I have no idea. So if you looked on the previous page, it said, how do you find the limits? Well, the way that you find the limits is you set these two functions equal to each other. Sorry, I wrote that wrong. It should be 3 minus x squared was our first function, and set that equal to 2x. I'm going to add x squared to both sides. I'm going to subtract 3 from both sides. Add x squared and subtract 3 from both sides to set this equal to 0. So I'm getting x squared plus 2x minus 3 equal to 0. This is a quadratic function. Again, you could use the quadratic formula or try to factor. I need two numbers that multiply to be -3 and add to be 2. I'm going to get x plus 3 times x minus 1 equals 0. I'm going to FOIL that out to double check. I'd have x squared minus x plus 3x, which would be 2x. Then I'd have minus 3, so it looks like I factored it properly. I set each one of those factors equal to 0. So I have x plus 3 equals 0, gives me x equals -3. I have x minus 1 equals 0, gives me x equals 1. So these numbers right here are my limits of integration. My lower limit, a, would be -3. My upper limit, b, would be 1. So now I know I'm going to be doing the integral from -3 to 1 of the top function minus the bottom function with respect to x, but again, I need to know which is the top function and which is the bottom function. I know what interval I care about now, but I don't know which one's the top function, which one's the bottom function. Well, here's the nice thing. The interval is -3 to 1. I know they're never equal to each other in that interval, so all I have to do is test one point in each one of those intervals to each one of the functions. So the first function was 3 minus x squared. The second function was 2x. I can pick any number in between -3 and 1. My favorite number to plug in, as always, is 0. 3 minus 0 squared gives me a 3. If I plug in 0 into the second function, 2 times 0 would be 0. The higher one is 3, so that is my top function. The lower one is 0, so my lower function would be 2x. So let's go back up here. Again, I'm trying to find the area between the two curves. Well, the place where these two curves is equal is -3 and 1. Now I need to do the top function. We determined the higher y value. The top function came from 3 minus x squared. And then from that, I need to subtract off the bottom function, which was 2x, the lower function that we determined there. I'm going to go ahead and clean this up, write it in descending order. This is the integral from -3 to 1 of, I would have -x squared, I'd have a minus 2x, and then I'd have a plus 3. All of that's with respect to x. So now that I've set up my definite integral, I actually need to evaluate it. I'm going to use the power rule here. The integral of -x squared would be -x cubed over 3. The integral of -2x would be -2x squared over 2. The integral of 3 is a positive 3x. Again, this is evaluated from -3 to 1. Clean it up a little bit as I evaluate it. So this would be -1/3. I need to plug in the top number first, so that would be 1 cubed. Those two simplify, so I'm going to get rid of that. So this would be -1 squared plus 3 times 1. So that's me evaluating it at the top value. Now I need to subtract off the evaluating it at the bottom value. So that would be -1/3 times -3 cubed minus -3 squared plus 3 times -3. I want you to be extremely careful with your negatives, be extremely careful with your parentheses. Plug that into your calculator and let's see what you're getting. I'm getting a fraction of 32/3. Again, do not trust me on this one. I could have made a typo. I want you to go ahead and redo this yourself to see what you are getting. So I just wanted to kind of give you a visual of what the heck just happened. What just happened was we considered two graphs. We considered 3 minus x squared, which would look something like that right there. 3 minus x squared, and the graph of 2x, which looks something like a steeper version of x. That would be something like this right here. So this would be y equals 2x, and this would be y equals 3 minus x squared. I'm just graphing both of those. We determined that the first place that they meet is when x equals -3. So this is a -3. And the second place that they meet is when x equals 1. So that would be right there. So what we were able to do is find the area. Notice it has to be positive because it is officially area. Okay, we found the area between those two curves, and if you notice, 3 minus x squared was on top in that interval, and 2x was on bottom in that interval. So that's what we did, is found the area of that shaded region, blue region right there, bounded between those two curves. We started with finding the places where they actually intersect. We tested which one's on top, which one's on bottom, and then we were able to evaluate it from there.